Hello everyone. Today we will discuss the concept of radius of gyration. So what is radius of gyration? Let me first define it, then I'll explain it. Radius of gyration is the distance from the axis of rotation at which if the whole mass of the body is placed gives the same moment of inertia value as given by the normal distribution of the mass in the body. What does it mean? We know that if a body is having a normal distribution of mass, whatever it is, and we consider that it has so many point masses. So if we consider this as first, and we consider all particles are having same mass. So the second particle is at suppose R2 distance, this first is at R1 distance, this third particle is at R3 distance, so and so on, nth particle at Rn distance, right? Then we know that what is the formula for moment of inertia? Moment of inertia is sigma m r square. And for radius of gyration, we are considering that if the whole mass is fixed at a point P at such a distance which gives the same value of moment of inertia as given by the normal distribution of mass. So if I place the whole mass, so I can write that sigma m is placed at point P. So this is the point P where the whole mass is placed, and at this distance, if the moment of inertia value, which is given by this, if this value is same as the one given by this, then we say that this is the radius of gyration of this body. So radius of gyration is that distance from the axis of rotation of the body where if we place the whole mass of the body, it gives the same moment of inertia value as given by the normal distribution of the mass in the body. So I can use this sign here which shows that these two are equivalent, because equivalent for moment of inertia for I value, right? So we can write that I is equal to mass into k square, right? So from here, first this is the basic formula which relates the radius of gyration with the moment of inertia, and we'll use this to derive a physical significant relation for radius of gyration. So that is from 1. I is equal to m r1 square plus m r2 square plus and so on m rn square if all the masses are considered to be equal. So if I take this m common, inside we will have r1 square plus r2 square plus r3 square plus and so on this. If I multiply and divide this expression by number of particles, right? So multiplying and dividing by number of particles. So if we do this, what will we get? We'll get I is equal to m into n, and here this will be r1 square plus r2 square plus r3 square plus and so on rn square upon n, right? And m into n will give you the total mass. If we have n number of particles and mass of one particle is small m, so total mass of the body will be small m into n, right? So this is m, and left side we can replace this by m k square. This is from equation 2. So here so this will be cancelled. So k is equal to under root r1 square plus r2 square plus dash dash rn square upon n. How can we name this? This is root of mean of the squared distances from the axis of rotation. So what is k? K can also be defined as, and this can also be written as significance of radius of gyration. So k or radius of gyration is the root mean square of the distances of the particles from the axis of rotation. So using this radius of gyration concept, we can calculate the moment of inertia of some complicated bodies. So this is also one of the significance, and but that is not in your course. So here we will take the moment of inertia of some standard bodies to find the radius of gyration of some standard bodies. So we know the moment of inertia of some standard bodies. For example, solid sphere, I is equal to 2 by 5 m r square. So we can find the radius of gyration value using the formula I is equal to m k square. So this is 1, this is 2, from 1 in 2, I will write 2 by 5 m r square is equal to m k square. So this will be cancelled. So k is given by r under root 2 upon 5. Generally we write the squared values also, that is the requirement, so we can keep it as it is also, that k square is equal to 2 by 5 r square. So we'll take another example. So let's take another example for this moment of inertia of a solid cylinder. So for solid cylinder, this is for solid cylinder. So we will again write this formula. So from 1 and 2, half m r square is equal to m k square. So this will be cancelled. So k square is equal to r square upon 2, or k is equal to r by root 2. So I think there is no need of much discussion over here. If you know the moment of inertia values of standard bodies, you can find the radius of gyration value for those bodies. So that's all for now. Um, we need to discuss one more thing here, that the factors on which this radius of gyration depends. First is the mass, second, selection of the axis of rotation, and distribution of mass about it. So that's all for now. Have a nice day.